Hey, guess what, guys? It's snowing. Hopefully we'll have enough snow on the ground here soon to build a snowman. But just in case not, I'm going to go ahead and film this pretty wintry intro video. So we are going to be doing one of the most useful things you can do with exponential functions, and that's compound interest formula. So it's a banking thing. It's a thing that shows up a lot when you're trying to work with your own finances. So it'll apply to everybody one day. So let's go ahead and get to it. Hi guys. All right, compound interest, as I said in the introduction, is one of the most useful things we do with exponential functions. Really, exponential functions get used a lot in all different aspects of real life, but compound interest, we use it when we're calculating how much interest you're going to be saving in a savings account. Also, credit cards use it when they're figuring out how much interest to charge you on your loan. So it's very important. We have a fun little quote that's attributed to Albert Einstein here. So basically what I'm saying is this is really important. This is something that could save you some money in the future or make you some money in the future. So learn it, listen up, and it's also going to be used in the next couple of lessons. So let's go ahead and look at what the compound interest formula is. Now, if I can go to the next page. It looks really complicated. Woo! It looks kind of complicated. There's a lot of variables going on here. There's a lot to it. But it is on your formula sheet, so you don't have to worry about memorizing it. What you need to memorize is, what do the different variables stand for? Okay, so all these letters. A stands for the amount accumulated after your given period of time. So that's going to be, most of the time, that's your outcome. That's the value that you're looking for. P stands for principal. That is the initial amount. So we put principal amount in there, but really it's your starting amount. It's your initial amount that you invested, or your initial loan amount, whichever the case may be. Your R up here, it's on the top of this little fraction, is your annual interest rate. This is going to be given as a percentage. You'll need to change it into a decimal, and when we get into some examples, I'll show you how to do that in case you forgot. N is our next variable. Notice that N shows up in two different places. So this value you're going to plug in twice, one at the bottom of this fraction here and one up in your exponent. N stands for the number of times per year the interest is compounded. So that's where that compound interest comes from. And then our last variable is pretty easy to figure out. It's T. It's your time in years, which goes right here. For compound interest, you are always going to be assuming that you're measuring in years. When we get into some other kinds of problems, the problem may tell you, okay, we're not measuring in years anymore, we're measuring in days or hours or something like that. But for compound interest, it's going to be years every time, so assume it's years. Right, so let's go ahead and make sure you get all that written down, and let's move into an example problem. Right, I copied this over so that y'all could still see it as I'm working through this, but it's also on your page, obviously. So let's make this smaller because I think it's easier to read. So you deposit $1,600 in a bank account. We want to find the balance after 3 years for each of the following situations. So we're going to do kind of 3 different practice problems. First thing I know, though, is that I'm depositing $1,600, which means that's my principal amount. That's that initial amount. It's going to go right here. Okay? And we know that it's being deposited for 3 years. So that's going to be my T. So this first example says the account pays 2.5%. There's my R, except remember I told you that it's going to be given to you as a percentage. You need to change it into a decimal. To change it into a decimal, you are going to move that decimal 2 places. So this R is actually going to be 0.025 or 25 thousandths. Right, so we've got our principal, we've got our rate, we've got our time. The only thing we don't have is the N, which is the number of times per year it's compounded. This says it's compounded monthly, so that means my N is equal to 12 because there are 12 months in a year. So when I write this out in this formula, I don't know my A, that's what I'm looking for. My principal amount, my initial amount, is 1,600. I'm going to open that parentheses, put a 1, that's always there, plus, and then I've got a fraction. On the top of the fraction goes my interest rate after I've changed it into a decimal, so 0.025. And then in the denominator of the fraction, I'm going to put my n, which in this case is 12 because it's compounded monthly. Then my exponent has got two pieces to it. It's got n times t. So 12 is my n times the number of years, and we were told to think about 3 years. So this is what my problem's going to look like. Now it's just a matter of you putting this in the calculator, and different people approach it different ways. I tend to just put all of this in the calculator at once. I might go ahead and multiply that 12 times 3 in my head, but everything else I'm just going to plug it straight into the calculator. Make sure though that you're putting all your parentheses in the same spot in the calculator as it is on your paper, because it's gonna change your order of operations if you're not careful. So you want to make sure it goes in correctly. So even though I'm doing this problem for you, I want you to take your calculator out and plug it in just to see if you end up getting the same thing as me. Because if you're not, then that means you're putting something in the calculator wrong and you need to raise your hand and get us to show you what you're doing wrong. Okay? So when I plug this in, I end up with 1,724. And then I've got 480098, but because this is money we're talking about, I'm going to round it. There's my dimes, there's my pennies. I'm going to round it to the nearest hundredths. So this is how much money I have in my account. Now, if I was asking how much interest did I earn, well, then I'm going to subtract off that initial 1,600 that I put in. So I earned 1,600 minus this gives me $124.48. So that's some free money over 3 years. It's not too shabby. All right, so let's look at how it changes when we do a different problem. So this time the account pays 1.75%, which means my R, remember we got to move it 2 decimal places. That is the most common mistake here. You'd think it'd be this crazy formula. It's not. It's forgetting to move that decimal. So move that, and we get this. And it's compounded quarterly. Quarterly means that it's being compounded 4 times. Quarters, like there are 4 quarters in a dollar, and there are 4 quarters in a football game. So n is equal to 4. So the only thing that's going to change here, I've got the same initial amount, because we're still talking about the same account. My 1 stays the same. My R, the top of that, or that numerator of that fraction, is going to be 0.0175, and my n is 4 now because I'm compounding it quarterly. And then in my exponent, my n is 4, my years are still 3. So now I've got 4 times 3 up here instead of 12 times 3. Okay, so again, I'm going to put this in the calculator. You should put it in as well, just to make sure that you're doing it correctly. So okay, and I forgot to close my, see, I'm going to make a mistake. I forgot to close my parentheses. Okay, so raised to the 4 times 3, and I got 1,686. Again, there's a whole lot of decimals, 0.051019, but I'm going to round it to the nearest penny, which means 0.05. This time I didn't earn as much money because my interest rate was lower and it was compounded fewer times. So this time the amount of interest earned was only $86.05, because again, you take out that 1,600 if we're asking how much interest is earned. This is asking for the balance, so you'll give this answer. But if we had asked for the interest earned, then you would need to subtract off that initial amount. Okay, this one's got a really high interest rate, but it's only compounded once a year, so let's see what happens there. My initial amount is the same. I've got my 1 plus my R. I'm going to move it 2 spaces, so it's 0.04 over, and yearly means your n is just 1. Okay, so we put 1, and then raised to the n times t is 1 times 3 years is 3. Okay, so let's put this in the calculator. 1600, open parentheses, 1 plus, I'm hitting that fraction button. and putting in 0.04, and then arrow down and put a 1, arrow over, close that parentheses, hit my little caret to go up into the exponent, and 1 times 3, or just 3, because 1 times 3 is 3. And what I get is 1,799, and my decimal is going to round to 78 cents. So when you have a 4% interest rate, you make nearly $200 in that 3 years. So definitely a high interest rate is what you want if you're trying to earn money. Now, if we're talking about a what's the word I'm looking for? A credit card, then that's going to be really painful when you're trying to not pay a lot in interest. Okay, so there is practice for this. There is not an application because really the practice is sort of an application type problem in itself. So make sure you do as much practice as you need, and then let us know when you're ready for your mastery check. Bye, guys.